So our next speaker is Vivek Prahlad. He is the senior developer at ThoughtWorks, currently heads the innovation and open source related activities there in India. He's played several roles, from being a technical lead, an agile coach, and a project manager. He blogs a lot, or occasionally, I guess, and he lives in Bangalore with his family. The talk is titled Functional Testing Swing Applications with Frankenstein. Vivek.
Thanks, Alan. I'd like to start off by thanking Alan and the organizers for inviting me. I've come here all the way from Bangalore. As somebody who gets to organize these kind of conferences back in Bangalore, I understand what Alan and his team have been through, probably putting this conference together. So a special thank you to all of you. Okay. So I'm going to start by asking a question to all of you. All of us know who this is, right? So if you think this is Frankenstein, that won't quite be accurate, right? So if any of you have read the book, the monster does not have a name. It's just called the monster, just like the thing from the Fantastic Four, right? So Frankenstein is actually the guy who built the monster. So all that I'm trying to say is that Frankenstein is not named after a monster at all, okay? Okay. Cool. So here's the agenda for today. We're going to start off with an introduction to Frankenstein. We're going to have a few demos in between. I'm going to spend quite a bit of time talking about what it takes to test multi-threaded user interface. That's something that's relevant, I feel, not just for Swing applications, but also for web applications, especially those that involve Ajax. And finally, we're going to have a round of Q&A. So what is Frankenstein? It's an open source record and play tool for testing Swing applications that supports testing multi-threaded user interfaces. So in terms of features, we'll get into that in a minute. But Frankenstein actually originated on what some of us know as a ThoughtWorks Atlas project, which was actually also the source for a few pretty interesting things. The first one of those was the first continuous integration tool. It was built on Atlas, a precursor to Fit, which was actually called the Coded Functional Test Framework. Pramod Sadlage actually did his first database refactoring work on the Atlas project as well, and that's also the source for Frankenstein. So when me and Chris Stevenson, a colleague of mine from ThoughtWorks, started work on Frankenstein, we had a few goals in place. The first one of those was that we had a lot of existing fit tests, but those tests, unfortunately, did not run against the user interface. So those tests were actually running at the business layer. That's what Fit is really good at. But they did not actually drive the actual user interface. And that was causing us some grief, because we were actually missing out on a few bugs that were actually UI related and not really all that closely related to business logic. So that was the first goal. Over the course of time, Frankenstein has deviated slightly from that goal, and it no longer integrates with Fit. One of the goals is, of course, to look at how you would have a Fit extension that would still use the existing framework. One of our other goals was to find better ways of testing multi-threaded Swing applications. One thing that we found is that none of the existing Swing frameworks that are out there actually looked at how you would address the multi-threading aspect. The application that we were actually trying to test had used multi-threading extensively, and we were finding it really tough to test it, mainly because you need to make guesses based on the size of the data sets that you would work with. So for instance, if you worked with a large data set, you would put in larger weights and pauses. If you worked with a smaller data set, you would end up putting in smaller weights and pauses, and so on. So that made it really, really difficult to test the application against varying data sets and all of that, right? Another design goal that we had was the ability to test custom components really easily. This was an application that had a lot of custom components. Unlike the web space, Swing actually allows you to define custom components fairly easily. For instance, it's quite simple for you to define fairly complex things like mapping components, date pickers, and so on, which you can also do in the web. But that presents its own challenges as far as Swing is concerned. So as far as features are concerned, Frankenstein supports record and play. Performance is one of the goals. One of the aims of the tool is to make sure that your tests run as fast as possible, but no faster. You'll see what that means in a moment. It comes with Ruby and Java drivers. So you can actually write a test that executes either in Ruby or with Java. It also allows you to make assertions on your user interface using the object graph navigation language, or OGNL, right? And that's something that's really useful if you want to arbitrarily test the properties of a given component. You'll see examples of that as we go on as well. Extension and integration was also a design goal. As I had mentioned earlier, we wanted the ability to test custom components, and that's something that Frankenstein allows you to do. Finally, there's also some built-in reporting that actually generates reports for you, taking screenshots on failure in case a test step actually fails. So with that, let's take a look at a demo. So what I'm going to show you right now is a sample application that comes bundled with the JDK called the Swingset. The reason why I've chosen this is because it actually shows all the different components that are available with Swing. Right? So if I just launch that, so that little app right there is a Swingset. That's a Frankenstein recorder that you see right behind you. And let's just start the recorder and see what happens. So what I'm going to do is concentrate on one particular part of the Swingset, which is actually the JTable demo. So going to click on the print button, cancel the print, which launches another dialog, click on OK, and that's about it. So let me just go back, stop, and play everything back again. And that's it. Right. So let me play that back a little bit slower, and I'll walk you through what's actually going on. So let me navigate back to where the application was initially. So it's clicking on that icon right on the right side, clicking on the print button, clicking on the cancel button, which will open up another dialog, and finally clicking on OK on that particular button. Right? So if you look back at the test, one thing that you'll notice is that, okay, another reason why I chose this particular example is because I don't have access to the source code, or I don't really want to make changes to the source code in order to test it. So that's one thing that Frankenstein supports. So you can test applications to which you don't have access to the source code, but it works best, obviously, in cases where you can actually modify the source code so that you can it's easier to test, right? One thing that you'll notice is that it does use some heuristics in order to identify components properly. So for instance, this little print button that you see right here is not just identified as a print button. It's actually within a labeled area called printing. And for that reason, it's actually recorded as printing.print right there. Yep. OK. So there are a few other things that I'd like to show you. Let me start off by recording. And let's assume that I'm typing in something here, selecting various kind of things from the selection mode. And one thing that you'll notice is that the recorder does not record additional steps. So one thing that the recorder tries to do is coalesce events in case you're interacting with the same component. The objective is to use a few heuristics to make sure that you minimize the size of your test script. It's very common when you're trying to use a recorder that you record a lot of information, right? So the objective is really to make sure that in case you happen to be interacting with the same component, that you just record one step, right? That applies for most of the components. There are places where it may not make sense, especially when you're clicking on buttons. So you'd probably want to record that as 2 clicks and not just as 1, right? So apart from that, it supports all the major Swing components that are out there. Now, in case you want to do assertions, I'll just show you how that works. I just want to check that the header field right there has the text ABC. So I'm going to do a control right click to do that. It highlights a field and records an assertion that looks something like that. Yep. So that's what the script actually looks like. And if I save it, let me just show you. Right? So the steps that I showed you previously, clicking on the print dialog, canceling it, and then clicking on the final dialog that opens, would translate to something like this. So start off by activating the window, clicking on a button called JTable, clicking on the printing print button, and so on. Right? Now, the interesting thing is, this script that gets generated is valid Ruby code as well. So that means you can actually write a Ruby test that uses the exact same steps. You can actually cut and paste the steps that you record into your Ruby test, and that will just work. So if you want to see what that looks like, so as a first level, what you could do is record a series of steps and embed that directly into the Ruby test, and you'll end up with something that looks like this, which is obviously exactly the same as what we saw earlier, right? So I'm going to actually run the test this time from Ruby, and let's see how that looks. So I've got my application running, and let me just launch that. Okay. I haven't yet got to the point where a demo has failed. So let's see how that goes. So the second test that you saw is actually going to fail, and there's a reason for that. Not quite sure why it's running that slow. It should actually be a lot faster than that. Okay, so I'm just going to kill this and run this once more. Let's give that a shot. Yeah, that's more like it. Okay. So one of the tests actually failed. Let me show you what the report that you would get would look like. So we ran 3 tests. The first 2 are very, very similar to each other, but there's one that actually failed. And if you look at the step that actually failed, you would see a screenshot of what the entire desktop looked like at the point of failure. The reason why I think it's important to take a screenshot of the entire desktop is because it's quite common that tests fail when you see a pop-up dialog show up from outside the application. For instance, if it's something like a Windows update on Windows or something on those lines, that would actually interfere with the test and cause it to fail. And that's one reason why I actually feel it's important to capture the entire desktop so that you can actually diagnose what the cause of the failure is, right? So apart from all that, those are the kind of assertions that you can do. You can actually assert the number of rows on a table. That's what a table row assertion looks like. You can basically just say it's row number 1, and after that, it's just a series of values that you want to check against. So the first column is going to be Mark. The next one is going to be Andrews. You don't really care about what the third column is. You do care about what the next column after that is, and so on. So anything is actually a regular expression that Frankenstein understands. It basically translates to match anything that shows up, obviously, right? So if I go back to the report, one thing that you'll notice is that you essentially get a series of steps. So the assert row that I showed you previously actually expands out to a series of assertions, all of which operate on one cell at a time, right? So if you look at what actually happens here, we're actually going cell by cell right here and checking whether each of the values are correct or not, right? And that actually means that in case you have an assert row failing, you can actually go down to the step that actually caused the problem. Okay. So So how does it work, right? So it's quite simple, really. It starts off by recorders that are specific to a particular component type. You're talking about text fields, combo boxes, check boxes, and so on, that hook onto the Swing event queue. Whenever a component is shown, at that point, the recorder would attach a component-specific listener. So for instance, if it's a text field, it would attach a document listener. If it's a combo box, it would attach a different type of listener. Whenever the user interacts with the user interface, it would actually record an event. As you saw from the first demo, it uses event coalescing to make sure that the size of the script is actually minimized. And events can actually replay themselves, effectively using the command pattern, right? And between each step, the framework actually does a synchronization to figure out, is there any kind of activity going on, whether it's threading or whether it's any kind of swing activity. And that's essentially what happens, right? So that's basically how Frankenstein works as far as record and play is concerned, right? So when we originally wrote Frankenstein, one of the things that we did was embed the recorder within the application. So in the last talk, we talked about how users would actually, we heard about how users would actually use the application in unexpected ways, and then it becomes difficult for the development team to figure out what actually happened. Did they go in an unexpected route? How do you actually reproduce the error? So that's one thing that we actually used the recorder feature for quite a bit, which was to actually record and then reproduce bugs. So whenever end users, analysts would actually find issues with the application, what they would do is they would be able to attach a Frankenstein script along with the bug, and that meant that the developers would be able to reproduce that particular issue on their machine, right? So obviously, it's not advisable to use recording to develop entire scenarios for a couple of reasons. The first one is, of course, that scripts tend to become really difficult to maintain. And the second thing is that when you're doing recording, you end up recording a lot more than you actually need for the test to pass, right? So recorders tend to be extremely verbose. They often record a lot more information than you actually need in order to make your test pass. So it's usually far better to record snippets of a user's workflow, because you can then use that to build a library that you can then reuse and build tests from. So that means that using this, if you're recording snippets of a workflow, what you'll be able to do is extract functions, parameterize, and then reuse them, right? So later, you could think about building your tests from a library of functions, and you'll see what that will look like in a moment, right? As I mentioned earlier, Frankenstein comes with a Ruby driver, and that is what actually helps you to make the test modular. So if you want an analogy, the recorder is very, very similar to the Selenium core and the Selenium recorder, and the kind of tests that you get are extremely similar. The difference is, of course, that if you're using a Ruby driver, it allows you to refactor your tests, use the kind of page object pattern that Simon talked about when he was describing WebDriver. And that actually helps you to make sure that your tests are dry and make sure that you don't have duplication, right? So then you can extract common steps into functions, parameterization again. Test suite support is only supported via Ruby at the moment. And it also gives you a pretty nice workflow for incrementally building tests. The reason for that is, of course, that Ruby is a dynamic language, a scripting language. What you can actually do is build your tests incrementally by executing portions of it as you go along. So one thing that I tend to do when I'm building my tests with Frankenstein is that I have a whole set of recipes that I use that actually gets the application that I'm testing into a series of states. So that's something that I found really useful. So instead of manually testing to a point and then recording from there, you could actually use a recipe to get you to a defined state in the application and then carry on from there. You could actually use that kind of an approach, not just for building your tests, but also for some sort of exploratory testing, if you so choose. Right. So why Ruby? There are a few reasons why. The first one is, of course, the focus on readability and ease of use. Brett Petticord, who's pretty well known in the Agile testing community, runs a workshop that he calls Scripting for Testers. The documentation for that particular course is just 3 pages. So if you actually want to use Ruby for test scripting, you actually don't need to use all the fancy metaprogramming stuff that Ruby actually provides you. You can actually, you just need to know the basics for how do you actually create classes, modules, functions, how do you define parameters and defaults, and that's usually enough to get you started. Of course, Ruby has a pretty rich ecosystem of libraries and gems that you can actually dip into. And that's something that you can always do at a later stage. So all of this essentially means that Ruby has a fairly short learning curve, and that makes it a great choice for scripting your tests. Another thing that you can do is that you can actually build testing DSLs for your application using the Ruby driver as the base in a manner somewhat similar to what Simon was talking about again in the morning, right? And obviously, if you want to, you can actually use a lot of libraries for doing various things. For instance, if you want to test the database, you can do that. If you want to do internationalization testing, your application happens to be supported in multiple languages, it's actually possible for you to write one test and then drive the same test with different types of data from different languages, right? If you want to data drive your tests from, say, an Excel sheet, you can do that. There are libraries available for CSV support, which can actually allow you to parameterize your data as well, right? So what that means is that it's possible for you to write a test that looks like this. So this is a very simple funds transfer example. You're logging in as a username with a password, checking that your current balance is 1,100, transferring $100 or whatever unit it is to a destination account, and then finally checking that your balance is 1,000, right? So the key thing to note here is that there's no description of the user interface. The test is written in the language of the domain, right? And one thing that you usually find when you write your test in this style is that even if there are UI changes, the test is still valid. So for instance, you could start off by doing the transfer on the same screen as a screen that actually displays your account. It is possible that later the UI changes and it moves out to a different screen or a different tab. So all that you would then need to change is really the transfer function that you see right there, right? And that's something that's really useful to do. So it's fantastic if your functional tests actually express the intent of what you're trying to test, right? That's something that we consider to be really important. Okay, so moving on, let's talk a bit about testing multi-threaded applications. Before we actually do that, I have a couple of definitions that I'm going to use. The first one is, what is a worker thread? I'm going to define it as background work that is actually triggered by a user action. So for instance, if you are running an IDE like Eclipse or IntelliJ, and you click on the Run Test button, and the tests actually start, I'm going to say that those kind of actions are actually done by worker threads, right? In contrast, you have what we call background threads. And these are basically background work that is triggered at periodic intervals by the application. In other words, the user does not really do anything that triggers off background work. An example of this would be an editor that automatically saves your text files at periodic intervals. It's not something that the user has too much of an influence on. It's something that the application decides and does, right? So when we're talking about multi-threaded user interfaces, my focus is going to be on the first kind of activity, which is basically worker threads, activity that is triggered in the background as a result of a user's action, right? So there are two basic approaches that you can use when you're testing multi-threaded user interfaces. The first one is to use what we call an arbitrary wait, right? So the basic idea is make a guess about how long a particular action is going to take. So if it's a login, okay, I enter my username, I enter my password, click on the login button. I assume that on an average, it would take around a minute or so. I'm going to make a guess and add a factor of safety and say that, okay, let's wait for a minute and a half for the login process to actually complete, and then let's go through the rest of the process. So that's really what the first approach is about. The second one is explicit synchronization, which is to look for indirect indications that your actions are actually complete, right? I'll show you an example of this in a moment, right? So if you use arbitrary waits, you have two issues. One of two things could happen. The first thing is that your test could be slow. And that will happen if you guess too high. So instead of a minute, you end up making a guess about 2 minutes. You basically end up slowing your tests down quite a bit. The second one is actually even worse. If you guess on the low side, then what's going to happen is that the actions that you thought would complete do not end up completing. And it's quite possible that the rest of your steps from that point on would start failing, right? So if you guess low, then your tests are going to be fragile, and your tests are likely to break. So here's an example in pseudocode. So logging in with a username and a password, waiting for approximately 20 seconds for the inbox to show up, navigating to the inbox, selecting all the mails, and then deleting them. Okay. Not sure why you do this, of course, but I hope that conveys what the intent is. The second technique, explicit synchronization. The issue with that is that your tests tend to be verbose. You tend to need to do this at periodic intervals, especially if you're, say, testing an Ajax application, right? So what you'll end up seeing is something like this. Log in with a username and password, wait for a label to show up. So most of the times you'd end up with your username showing up in the top right corner, if it's an email client like Gmail or anything else, right? So you're actually saying, I know that I've logged into the system if I see a label with my name showing up in the top right corner, right? So that's what explicit synchronization means. And then, of course, you would go through the next other steps. Okay. So to summarize, right, there are issues with both of the approaches, right? And I'm going to go out on a limb and say wait is considered evil, right, for the reasons that I mentioned before. And wait for is also considered evil, but it's a bit of a lesser evil, if I may say so, right? That's because using the wait for technique, your tests tend to be a lot more stable than the previous approach, right? So the question that Chris and me asked ourselves when we wrote Frankenstein was, is there a better way of doing this, right? What happens if instead of waiting for things to happen explicitly, what happens if you try and do these waits implicitly? How does that impact the test? And how does that change the way that you do your testing? So Frankenstein's approach as far as multi-threaded testing is concerned is that scripts do not need to worry about threading issues. So in a lot of ways, you could say that the multi-threading aspect of an application is just that, an aspect. It's a cross-cutting concern. It's not something that scripts actually or your test scripts actually need to worry about. The framework takes care of monitoring what's going on with the system for you. So there are several ways of doing this, but one of the ways in which you can take advantage of this fairly easily is to decide on a worker thread naming convention. So for instance, it's quite common for you to use something like a UI worker and then a counter in order to name your threads. And if you do that, then Frankenstein can actually monitor the threads in your system after every test step and make sure that there's no threading activity going on. Obviously, if you're building your own custom worker thread infrastructure, it's quite possible that you would use something like a thread pool, and then you have the option of implementing your own monitor, right? Which will also work. So what that translates to is as soon as waiting for user activity becomes implicit, your test scripts end up being a lot shorter and a lot more robust. So the same test that I showed you previously just no longer requires the need for a wait, right? So let me show you an example of that in action. A very simple and slightly contrived application, but we'll see that. Okay, that's because I've got too many of these actually running. Let me just shut that down. And there we go. Okay. So I'll just show you what this does. What I'm going to do is I'm going to click on the Start Long Process button. That's actually going to create a background thread that will do some work for a random amount of time. So if I click on it right now, it's going to take approximately 10 seconds. 10 seconds later, that Show Dialog button that you see on the right is going to get enabled. That's the only time I'll be able to click on it, and then it will do something else. So there it is. It's done with its activity in the background. And we click on the Show Dialog button and click on No, right? So let me just record that. 5 seconds, I'll have to wait until that finishes. There you go. And no. Okay, so let me stop that and play this back again. Remember that the wait is going to be random. So let's see what happens this time. 10 seconds. So 10 seconds later, the Show Dialog button should actually get enabled, and then the rest of the test should actually proceed. okay? And if I do it again, okay, just 1 second this time, and that's it, right? And that's the whole point. As you saw, I didn't really know how long it's going to take for the long process to finish. Now, assume that this is a login process. Your servers are under a lot of load, and for some reason it takes you, say, 10 seconds or 15 seconds for you to log in. You wouldn't really want your test to fail, right? What we're really trying to do is make sure that your tests are stable by actually providing the testing framework an indication of what's actually going on with your system. And the way that we do that is by actually deciding on a worker thread naming convention. So for instance, when I clicked on the start long process button, the thread that I spawn off to do the background activity, which if you remember, I'm referring to as a worker thread, is named in a particular way that Frankenstein actually understands. And that's what enables it to monitor what's actually going on with the system, right? So as you can see, what that ends up doing is your test itself no longer needs to have any weights in there to make it pass, right? Cool. Okay. So moving on to assertions. As you saw previously, a control right click on text and labels will actually record assertions, which you can then replay. You need to add additional assertions manually using the Ruby driver. The API actually has quite a few of them. You saw one of them, which was the assert table row. There's several others that are more component specific. Right? It's also possible for you to assert arbitrary properties via OGNL. So the general format of that kind of an assertion is something like this. You would assert that a property on a given component has a certain value. And an example of that is something like this. So if you've got a table called table name, and you want to figure out the number of rows that it has, row count is a property of the table model, and you would then check that the value of that row count is 1. In other words, what we're doing is checking whether the table has a single row. Now, that expression that you saw right there translates almost exactly to this, which is a JUnit assertion, which just says table.getTableModel.rowCount. And the nice thing is that using OGNL actually makes it possible for you to record a whole host of assertions. Not all of them need to be actually in Frankenstein for you to start off. So for instance, if you want to check whether a given component is enabled or not, you'd use an expression very, very similar to this, and you'd be able to actually do your work. Right? If necessary, you can even make method calls and assert against them. And in fact, if you saw the original assert table row example, that actually did a method call to figure out what the value of a particular cell was. Right? If you're interested in more examples, there is a Ruby driver, and that actually has a lot more of the kind of assertions that you can do. Right? So what does it take to integrate your application with Frankenstein? Right? So as I mentioned earlier, Frankenstein can be used for both categories of applications, those in which you can modify the source code and those in which you can't. It obviously works a whole lot better in case you can actually modify the source code. So the way to do that is actually to use logical names for your components. This is completely analogous to using IDs and names if it's a web application. The same kind of principle holds here as well. It's possible for you to do something very, very similar with Swing using the setName API, which is on the base component class. Right. Now, if your application is multi-threaded, you have two choices. You can either decide on a worker thread naming convention and tell Frankenstein about it, or you can roll your own worker thread monitor, which is what you do in case you had a thread pool framework for your workers. Right. As far as launching the application under test is concerned, the strategy that Frankenstein actually uses is to launch the framework first and then get the framework to launch your application. So there are two ways of doing this again. The first one is to use what I call a piping main. So how that works is, let's say that the command to actually launch your application is something like Java, a bunch of arguments, and then the main class name. All that you need to do is put in the piping name class name in front of your main class name, and that's all that it'll take. So for instance, so let's say that's what the command that you use for launching an application. All that you would need to do is and that. So as the name suggests, all that you have to do is pipe the actual class or the application under test through the piping main, launching the Frankenstein framework and then the application under test. Okay. So Frankenstein is still under fairly active development, but this is what the roadmap looks like. Right now, the Ruby stuff that you just saw does not really integrate with RUnit. So one of the goals is to integrate with RUnit and possibly RSpec. The Ruby integration actually works in a client-server kind of model. So there's actually nothing to stop you from doing the equivalent of MapReduce for test distribution. You could actually distribute your tests across multiple machines because it uses that client-server architecture, right? But one of the things that you could do is tighter JRuby integration, which has some advantages as far as monitoring what's actually going on with the system is concerned, right? The tests that you saw previously that I ran with via Ruby would also run equally well with JRuby as well. GNLP and applet testing is still in progress at this point. Drag and drop support is currently missing, but that's going to be added as well. Tree editor support, it does support testing tables and fairly complex tables at the moment, but that's tree editor support is something that Frankenstein lacks. And custom renderers. Now, Swing is a framework, as I mentioned earlier, where it's possible to customize almost any aspect of what the user interface looks like, right? So that means that you can actually decide how will a dropdown display its elements, how will a list look, how will a table look. You can define all sorts of custom stuff. And in order to do that, it's very common for you to define what we call a custom renderer, right? So most testing frameworks seem to choose the approach of asking you to decide on a convention at the model level. So that means if you have a table that consists of multiple rows, they would expect you to have a string representation of what every cell looks like. So we're going to try and take a contrarian kind of approach and approach custom UIs that use custom renderers from the user interface point of view, which means look at the UI and see whether you can break that down into a string representation, right? Okay. So that's where you can actually get hold of Frankenstein. It's at openqa.org, same place as Selenium. It's a small but growing user community. But my invitation to all of you would be, if you're interested, do participate. That's what open source is all about. And that will only make the tool a lot better than where it is right now. Yep. So I think I'm more or less done, and now we're open for questions.
Okay, I've got a question here. Here?
Okay. Good.
I actually have two questions. One question would be, if I, for example, for the logon or something, I want to specify a maximum wait time. So for example, very often we have requirements like, okay, we have to do a logon, but it might take up to 10 minutes, or it might take even longer, but it's only allowed to take 10 minutes. Can I, 10 seconds. Can I somehow specify something like this, and Frankenstein will test that, or?
Yes, you can do that. So your question was, how do you actually put in a test that asserts something that's time-based, right?
Yeah.
How do you assert that something takes a certain amount of time?
Yeah.
So Frankenstein is an event-based framework. And one thing that I talked about earlier was that one of the goals was to make it easy to extend. So one thing that you can do for that particular case that you talked about would be to define a custom event. Right? Mm-hmm. I'll show you an example of what that looks like. Fairly simple. For instance, this is how you could implement a delay. Let me just open that out. So that's just around 4 lines of code. All you need to do is extract from the abstract Frankenstein event, do a little bit of parsing to figure out what the test script line was actually. In this case, it extracts out the duration for which the delay should be done. When you run this particular event, what it'll end up doing is sleeping for that duration, right? So as I said earlier, essentially events are analogous to commands. So what you could do for that case that you talked about was do one that starts off a timer and then stops after a defined series of steps, and then does a check to see if the amount of time that it actually took was more or less. So I assume that you're talking about doing this either for performance testing or for something on those lines, or for validating whether the system behaves as expected, right? Yep.
Okay, and I've got another question.
Sure.
When you record something and you pressed on the print button, this was like, okay, and you've got the name print. You said before, like, you should actually use this set name of a component.
Right.
So is there an option to specify like which value of the component to monitor or to take in there?
Okay, so the way that the recorder was working against the swing set, it was actually relying on a custom naming strategy. So that's what Frankenstein falls back on in case you have not assigned logical names. So in case you have assigned logical names, then it takes that as the default.
Okay,
right?
cool.
Yeah. So it uses a heuristic to define what the name for a button should actually be. Right?
Got a question. Does Frankenstein easily support running these tests in parallel somehow?
Not in parallel, but you could actually look at distributing your tests across multiple machines. That is definitely possible. As I mentioned earlier, the Ruby to Java integration is a client-server kind of protocol. So what effectively ends up happening is that the Ruby side is a test generator. It does not actually drive the user interface directly. So what the Ruby infrastructure does is generate a test, right, in completion, send the whole lot over to the Java side, and the Java engine effectively runs the whole thing for you and reports back the results. So that means that you can actually remote control a Swing user interface from a different machine. And that means you could look at, say, spraying, say, 10 tests across 10 different machines in parallel, collecting the results, and then reporting on it. So that's what I referred to when I said you could do the equivalent of a MapReduce for testing, right, using the Ruby infrastructure.
So another question. I'm not very familiar with Swing, but would it be possible to run several of these tests on a single machine, say a Windows desktop, in parallel?
Okay, so one thing that you have to watch out for is focus-related issues, right? So especially if you've got things like modal dialogues and that kind of stuff, it's usually very, very difficult to do that kind of activity in parallel. So again, the considerations are somewhat different from web testing. If you write your web testing framework well, it's actually possible for you to not rely too much on focus. But with Swing, it's a lot more difficult to do that. So my answer right now would be no, it isn't possible. But it's definitely possible for you to run your tests in parallel across multiple machines.
Right, so it seems to be just like Windows Forms in that respect.
Sorry?
It seems to be just like Windows Forms in that respect.
Yeah, that's right.
Thank you.
Hello. Hi. Over here, I have a question for you.
Sure.
I guess it's concerning script maintenance. You alluded to that if there's a modification, version 1, version 2, is it a fair statement to say that you have issues dealing, like, say, buttons are moved, a field is moved from the upper right-hand corner to lower left, or cancel and enter are, transposed? How would you handle that?
Okay, so if you notice the test scripts, none of them actually had any kind of location-specific information. So if we have the case that you talked about where a cancel button moved from the top left corner to the bottom right corner, the test would still work. What I was referring to is when the UI changes fairly drastically. And by that I mean, let's say a certain series of components that you're working with move into a separate tab altogether. They're no longer visible. In order to activate them, you need to click on a particular tab and then navigate to them. That's really what I was talking about. And in order to do that, it's actually possible for you to refactor your tests or maybe rewrite small portions of your tests. But what really helps is to use the kind of approach that Simon was talking about earlier, where you actually have page objects and you have operations, he called them services, that are available on those particular objects. So for instance, I'll give you a simple example. So let's say that you got a simple login screen in which you type your username and a password, and then you add a little checkbox that says, remember me. So that's a change that we have made to the user interface, right? Now, if you actually pull out a login method, right, with the username and the password, and let's say that it takes into account the default state of the checkbox, then that's the change that you could make to the login method itself. You'd add an additional line that took into account what should you do to the checkbox in order to make your existing test pass. You could then define an additional login method, right? That allowed you to parameterize what you do with the checkbox. Do you remember? Do you not remember? And so on. So that's something that I found works fairly well. And then, of course, you could refactor those particular kind of scenarios out into highly general scenarios, which take into account all the things, what's in the username field, what's in the password field, what happens to the checkbox, and also rely on some defaults, as in what should be the default state of the checkbox be, if it's not the most important thing that you're interested in testing.
Okay, right. So I would just have to rewrite some code to deal with that.
Yeah,
okay.
But what I'm really getting at is that if you write your screen objects well, then the amount of change that you need to do tends to be fairly minimal.
Okay, thank you.
Hello. I'm used to some more commercial GUI testing tools where you can find a window and record all the children from that window rather than record and playback. And I'm wondering if there's any future possibility of that existing in Frankenstein. In other words, I open a window, I collect all the children from that window, and then I have a library of objects, rather than waiting for objects to show up in my library based on what I recorded.
Okay, so you're talking about basically building a screen map and using the screen map to write your tests? Is that what you're referring to?
Correct.
Okay, yeah, no reason why that should not be possible. Again, with the approach that the Ruby driver takes, of essentially being a script generator, that should definitely be a possibility. Because you could look at the recording process itself, generating a screen map for every screen, and then you would have the ability to do operations on those elements. So again, no reason why you should not be able to do that. I can actually show you something that you can do similar to that, but not quite. It's around test analysis, right? So one thing that becomes interesting when you use a driver approach is that, let's assume you got a test like this, right? I've omitted a lot of steps, but what I'm interested in checking, right, from a test analysis point of view is, do I end up where I started? So a common testing pattern that we tend to use is make sure that your test returns the application to the original state that it was in before you ran the test, right? And that's one way of analyzing it. You can actually run an analyzer through the test and then do checks that look something similar to this, right? So that first little test brings you back to the original step. This one doesn't, right? And that could possibly be an error. This one brings you back after showing you a dialog. So it shows you the main window, takes you to a dialog, shows you back to the main window. And the way that we are analyzing this test is actually not by executing it, so to speak, right? So what we are essentially doing is using an instrumented driver of sorts that actually figures out what states does the application actually go through without necessarily driving the user interface. So it's actually possible to do some pretty interesting stuff on those lines. But yes, again, the screen map idea should definitely work.
Okay, thank you.
Cool.
Any more questions? All right, Vivek, thank you very much.
Thank you.